These are the notes about stars, and then we'll follow it right up with the notes about galaxies. A star is a body of gases that gives off tremendous amounts of energy in the form of light and heat. What star is closest to the Earth? It's actually the sun. A lot of people don't think of the sun as being a star, but it is, and it is the closest one to us on Earth. It's about 150,000 kilometers from Earth, which is the same as that 93 million miles that we learned about before, which is the same as one astronomical unit. And that AU is the unit to measure distance that we use in astronomy. Are all stars the same? They definitely are not. And they are different by a whole lot of different things, like color. They can be different in their size as well as their mass, their composition or what they're made of, their temperature, and the distance from Earth can, of course, be different, which would affect its brightness because the brightness is going to be affected by how far away or how close it is. If stars are so far away, how do we know what they're made of? It's called the spectrum analysis of visible light. And we use a spectroscope to be able to analyze what the star is made of. And a spectroscope separates light into different colors and wavelengths. And at the end of the PowerPoint, I've got an example of this. And we'll actually hopefully do a lab about this as well. Stars are composed of gaseous elements, and each element emits a different color. And based on that different color, you can figure out what the star is made of. And of course, the two most common elements are hydrogen and helium. Remember that fusion process that we talked about with the sun? That's why hydrogen and helium are the two most common gases. How hot are stars? The temperature is indicated by the color of the star. Blue stars are very hot. That's the hottest star, which is kind of different than what you might think. Blue usually means cold, but in this case it doesn't. Blue means as hot as it can be. Red stars are actually very cool, which again is the opposite of what you might think. But red stars are the coolest. Yellow stars are medium. And of course, our star, the sun, is yellow, so it would be a medium. It's classified as a red yellow, which is about 5,500 degrees Celsius. Brightness is measured by the apparent visual magnitude on a scale of 1 to 6, 1 being the brightest, 6 being the most faint, or the dimmest, I guess. And the measured brightness is seen from Earth. So it doesn't measure the luminosity, which is actually how much light the star gives off. This is measuring how bright it seems from the Earth. Absolute magnitude expresses the luminosity of stars as if they were seen from the same distance. So basically this is saying you're putting two stars next to each other, and whichever one is the brightest has the higher absolute magnitude. The example here is that Sirius has an apparent magnitude 10 times greater than Antares, but Antares has a luminosity which is 250 times greater than Sirius. So Antares is brighter, gives off more light, but from Earth, Sirius looks brighter than Antares. So it's a little bit confusing. The motion of a star, just like the planets rotate and revolve around the sun, stars also move as well. They can move in three different ways. They can rotate on their own axis, just the spinning around, revolving around another star. Not all the stars do that, obviously, though. And they can move toward or away from Earth. Most galaxies appear to have stars that are moving away from the Earth. And that's what's called the Doppler effect, as well as that sound that you're hearing. The apparent shift in the wavelength of light. As something gets closer, it gets louder. As it moves further away, it gets quieter. And the stars that are moving away from Earth are obviously going to get. The blue shift occurs because the light waves from the star appear to be shorter as the star moves toward the Earth. And the opposite is called the red shift, when it appears to be moving further away. How is distance of a star measured? In light years. Kind of like Buzz Lightyear. He was an astronaut. He was going to zoom through space. A light year is the distance light travels in 1 year. So the time it takes for the light to go in a year, however far that is. Light travels approximately 9.5 trillion kilometers in 1 year. So that is a light year. It takes light from the sun about 8 minutes to reach Earth, or 8 light minutes. The closest star system to Earth is called Alpha Centauri. A little bit about stellar evolution, or how the stars have evolved. Stars are formed from huge clouds of dust and gas called nebula. Usually about 65% hydrogen and 30% helium. And of course, that hydrogen is going to be decreasing as it fuses with that fusion process into the helium. Gravitational pull causes nebula to shrink inward, and then they begin to spin. This nebula, like others, will eventually form a protostar. So the nebula turns into a protostar, which eventually turns into a star. And this nebula is called the Horsehead Nebula. See if you can kind of identify the features. This would be the nose of the horse, and then that would be the ears of the horse, and then the top of the head. And as we continue on with the star's life cycle, a protostar is a concentric cloud of dust and gas that spins and shrinks. And essentially, as it shrinks, it begins to spin. And it takes several million years for this to happen. When the temperature equals 15 million degrees Celsius, it causes that hydrogen fusion to begin and move over into helium, and will eventually become a main sequence star. A main sequence star is what our sun is. These stars are generally stable. The hydrogen atoms are combining to form helium, and the gravitational pull pushing inward is equal to the ones pushing outward, so that's why it's stable. Nothing's really happening with the star itself except for that hydrogen to helium. A red giant is the next stage, a very large cooling star. When the star begins to run out of hydrogen, the inward force becomes greater, putting lots of pressure on the core, causing the helium to form carbon. This fusion releases massive amounts of energy, causing the star to enlarge to a red giant or a supergiant. So, if we remember from before, the sun is that medium, stable main sequence star, and eventually it'll turn into this red giant or supergiant phase. Dwarf stars form when that helium fusion stops. The outer gravity pushing inward causes the star to begin to collapse. And then a white dwarf will still emit light, but a black dwarf no longer emits light and is the last stage of that star. A white dwarf that explodes into a black dwarf is called a nova. And then you can have a supernova. These are stars that are 16 to 30 times larger than our sun, and when it explodes, it is 100 times brighter than a nova. So that's the before, that's the after. A neutron star will form after an explosion of a supernova. The core contracts into a dense ball of neutrons. Some will emit beams of radiation and are called pulsars, like the neutron star above. You can see all the radiation, all the different colors. And then black holes. Everybody loves to hear about these. It is a supernova whose size is 30 to 15 times that of our sun. Because of the tremendous amounts of gravitational forces, the star collapses into a core with such force that no light or radiation can escape. And now we're going to get into the galaxies. How did the universe come into being? The Big Bang Theory. Not the show, but the theory about how the universe came into being. The universe used to be a sphere of hydrogen, which about 15 billion years ago, that's what the BYA means, it exploded, forming a gigantic expanding cloud. The cloud eventually moved apart, forming the universe as we know it. And as it's continued to spread, the universe has continued to evolve. What do we call the major components of the universe? Those would be galaxies, which is a large-scale group of stars bound together by the gravitational attraction. A typical galaxy is about 100,000 light years in diameter and contains billions of stars, gas, and dust clouds. So essentially we have the universe, that's everything that there is, and then the universe is divided into galaxies. The galaxies are divided up into stars and planets, and then, of course, we break those planets down into their different characteristics, which we've learned about. And then there are people, these little tiny, minuscule things that live on Earth. What galaxy are we in? Think about the candy bar, the Milky Way. And the two other closest galaxies to us are called the Large Magellanic Cloud, which is 179 light years away, which is still pretty far, and the Small Magellanic Cloud, which is 210 light years away. And you can see both of these sometimes in the southern hemisphere. If you were in the southern hemisphere, you would be able to see them. But we can't because we're in the northern hemisphere. And then you've got pictures of the Large and the Small Magellanic Cloud. And then there are three types of galaxies. You need to know all three, but they should be sort of easy to remember. The spiral galaxy has a center of bright stars with flattened arms of stars that spiral around the center. The elliptical is a very bright center. It has little dust and gas and is generally an older type galaxy. And these are just the exact shapes that the word describes. And then irregular is smaller and fainter, and the stars are spread out unevenly, so there's really no major shape to it. Quasars were discovered in 1961. They look like stars that emit radio waves. They're larger and more massive in size, and they're the most luminous stars in the sky, the brightest ones. The ones putting off the most light are quasars. Andromeda, which is 29 million light years away, can be seen sometimes from the northern hemisphere. And then the Whirlpool Galaxy, which is 37 million light years away. You can see how Andromeda is the elliptical shape, and the Whirlpool Galaxy is, of course, the spiral shape, because you've got the bright center with the arms coming off. And then Virgo would be an irregular shape because there's no specific shape to it, which is 60 million light years away. The Small Magellanic is irregular, no specific shape to it. And then when we study the stars in the galaxies, a lot of times you're talking constellations. The stars sort of come together to make certain shapes that ancient astronomers have given. And you've got Orion here, a warrior. He's got a shield. You can usually identify him most easily from the three stars that come together and make his belt. And then parallax is used to calculate the distance between two stars, a certain way that you can measure. And then this is the example that I was talking about at the beginning with the spectrum analysis. And using the spectroscope, which again, hopefully we'll get to do the lab with that. By analyzing and comparing the different spectra, you can figure out what elements make up the atmospheres of stars and planets. So when we use the spectroscopes, you'll actually see something that looks like this emission spectrum. And then by looking at the light that is produced in the different colors, we can take that to a main key and see what elements are actually being shown to us there. So the emission spectrum are the colors that are being given off. The absorption spectrum are the colors that are being absorbed. So where all of these black lines are match up to this emission spectrum up here. Whereas you've got the continuous spectrum without any breaks or anything, and it just does the Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet, straight across.